Alrighty, friends. So in this screencast, we're going to spend about 10 minutes or so talking about the quotient rule for derivatives, how we take derivatives of quotients. So let's do this. This is the quotient rule. The quotient rule says, if I have the derivative with respect to x of a quotient u over v, that is v of x times u prime of x minus u of x times v prime of x over v of x squared. That is so counterintuitive. You see some similarities to the product rule. You've got one times the derivative of another, the other times the derivative of a one. In the product rule, they were added. Here, they're subtracted. But there's this over v of x squared piece, and that's new. So I want to prove it to you because you should feel comfortable that this thing is actually true. I'm going to take the limit as h approaches 0 of u of x plus h over v of x plus h minus u of x over v of x all over h. And I know what you're saying. You're saying, why is there this big space in the middle? Well, there's this big space in the middle because for reasons that are unimportant to the story, I'm going to subtract and add at will u of x over v of x plus h. U of x over v of x plus h. And you're saying, what? Why would I do that? And then you sort of see what's happening here. Sort of. You know that we're going to end up with two fractions. Let's look at what's over here first. It appears that the over v of x plus h is a common factor. We can pull that out. And then what's left is u of x plus h minus u of x over h. And you're saying, I think I might know what that is. And then over here, we have the u of x in common, so we can pull that out. And then it's a matter of what's left. And what's left, well, how do you combine fractions whose denominators are different? You come up with a nice common denominator. And the common denominator on that is v of x plus h. And then your numerator, well, this fraction doesn't have a v of x, so that gets multiplied. This fraction doesn't have a v of x plus h. That comes up on top. And you're thinking, that does not look at all like this thing. Not at all. Because what it appears that this is 1 over v of x times this is, as h approaches 0, the derivative of u. And then here, u of x is utterly unaffected. And then this thing, what the heck is this thing? Well, this looks like the negative of v prime. And that is, in fact, what it is. It's the negative of v prime. So over v of x plus, getting close to 0, v of x squared. And so how do we make this all right? Well, if I want to get this to have a common denominator with this, I need an extra factor of v of x, but I can't just put that down there. It's got to be over here. And so what do I have? I have the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. It's the bottom times the derivative of the top minus the top times the derivative of the bottom. For the rest, you won't be scared. It's all over the bottom squared. This is calc, this is calc, this is calc. Yes, I just did that. Yes, I did. Yes, I did. Let me show you what it looks like. Yes, I did. And you just paused and called your roommate in and said, you've got to hear this. And that's, I don't know how I feel about that. It's a little bit creepy. There it is. So let's take a derivative. Taking a derivative should be straightforward because we have a song. It's the bottom times the derivative of the top. Now the derivative of the top, the derivative of a constant is 0. The derivative of a line is its slope. Minus the top times the derivative of the bottom. We know the derivative of x squared is 2x to the 1, and the derivative of x is 1, and the derivative of a number is 0. For the rest, you won't be scared. It's all over the bottom squared. This is calc, this is calc, this is calc. Now, we are not requiring you to simplify that numerator, but if you did, that's okay too. I'll show you one more. Here's g of x. G of x is x over 3x squared plus 1. Well, I know how to do that. It's the bottom times the derivative of the top minus the top times the derivative of the bottom. Yes, for the rest you won't be scared. It's all over the bottom squared. This is calc, this is calc, this is calc. Now, I would have left it in this form, but some people are going to simplify, and that's fine too. Cool? Cool. One more. Something to consider on your own. I want to find the equation of the tangent line to y equals x over x plus 1 times x squared plus 1 at the point 1, 1/4. I want to know what the equation of that tangent line is, and I know what you're saying. I know how to find the equation of a tangent line. It's y minus y1 equals x minus x1 multiplied by the slope. And then how do we find the slope? Well, that's easy. That's quotient rule, but careful. That's a quotient, but that's a product. So take a moment, do the quotient rule, pause in the middle of the quotient rule song for the product rule song, and we'll see what we get. Hopefully, you got that. Fingers crossed. Okay, if you did, fantastic. If you didn't, please ask somebody about it. So there it is. Okay, that's all. Thanks, everybody.